talk about highly modified binder yield performance gains for an I-40 project. Do you hate doing surveys? I hate doing surveys because I'm so busy. I mean, who's not busy these days? And then the second worst thing is presentations. But what I find, what I find out when I do these surveys and presentations, I learn something along the way. I guess it comes back from days when I used to teach school a little bit. Actually, when you teach people, you learn more yourself. So hopefully you'll learn something from what I present. But, you know, I had another college professor. He's an English professor, and he wrote me up one time. He said, "You use too many cliches." And I said, "What's a cliche?" So, you know, 3 times a charm. Has anyone heard me speak here before? 1? Have you heard me speak twice here before? Okay. Well, this is my 3rd time speaking here. I spoke here in 2011, 2014, so couldn't wait another 3 years. I guess you had to have me back. So good. I wondered whether I would be able to even get in here with all the weather you have here with the fog and the rain. And I love rain myself, particularly when I'm at home. And my plane was delayed an hour because of fog. They had to go to Portland to get a plane to get to Oklahoma City. I thought, well, I was wondering whether you'll like this presentation. Let's see. So what I want to talk about is the National Center for Asphalt Technology 2009 cycle in our section N8 and our Caddo County project on I-40, which is about 40 miles west of Oklahoma City. Oklahoma City is in the central part of Oklahoma, if you're not familiar with that. Talk about our 3-year fatigue research project at OU, our long-term pavement performance SPS section, SPS-10, that's just west of Oklahoma City, just west of Yukon, which is the next town west of Oklahoma City. It's practically a suburb, it's so big. It's where I graduated from high school, so I know the area pretty well. And that, if you're not familiar with that project, they're looking at long-term performance of warm mix asphalt and recycling agents and shingles and wrap. So it's kind of interesting thing we're doing there. And the Wagner County project, we're using ground tire rubber, which is, Wagner County is just a little bit to the southeast of Tulsa, which is in our northeastern part of the state. And then I'll kind of sum all this up with a few conclusions. So at the NCAT test track, if you see the diagram, I don't know if you're familiar with this or not, we have 2 sections there, N8 and N9. We started those in 2016 doing a perpetual pavement experiment. And N9 was 14 inches using a rich bottom layer. That means increased asphalt content in that bottom layer. And then the N8 was a 10-inch section. And we had soil imported to create a weak subgrade so that we could simulate what Oklahoma does, because there's really strong subgrades out there at the NCAT test track. Well, there's another thing. If you go to their website, you go on their construction link, you can select the sections and get more detailed construction information. And you can't get our past data, but this is what it looked like back then. And like I said, it's a 10-inch pavement, but at the end of the cycle, we have 10 million equivalent single axle loads. That's 18,000 pounds per axle, kind of like the axle on a semi, over a 2-year period, which is a moderate volume interstate highway level maybe. And at the 3rd year of that cycle, they analyze the pavement and do a report. Well, at the end of that cycle, the N8 section had significant bottom-up cracking. And we thought, well, in 2009, let's mill and replace 5 inches of it, and let's try to retard that cracking with fabrics. If anyone has ever been on the road and milled up a pavement, then you don't like fabrics, I'm sure. But that's the benefit of fabric. And we wanted to lay that bottom-up fatigue cracking. Well, that's the two fabrics that we use, the white fabric there in the foreground, and then in the background there's the other one. It's actually looking the opposite direction from the photos that you saw earlier. I don't know if that shows up too well, but there's a lot of rutting and pushing and shoving in some of those sections. And this was like at 3.2 million, so that's about 3 years of life in the pavement. So that's about what you would expect to see the cracking retarded, but not this kind of failure. Initially, I was seeing cracking outside of those fabric areas. That's cool, fabric's doing what it's supposed to. And then a few more cycles later, loading of traffic, these heavily loaded trucks, then we started getting this, and then they had to detour around our section because it was unsafe for the drivers. Well, after we, this 3.5 million easels or so, we milled and replaced with a PG76E -28. That's extremely high traffic according to Master Grading System. Kraton polymer, they had suggested using this, them and NCAT's Dr. Nam Tran, based off the good performance of N7 that Kraton had used this high polymer and thin lifts compared to the rest of the section of the track. And these are about the levels that we're doing. You kind of notice that we're using this highly fine aggregate, which you normally wouldn't use as a surface course. And then we're also using as a third lift down. And I call this rich intermediate layer, which is actually the same thing, only 0.2% more binder, essentially. BMA's increased accordingly. So the concept there is, okay, it's kind of like a eraser. If you take an eraser and you bend it, you see these tensile stresses causing these cracks at the bottom, and then you get this compression that's in the top part where you're doing. So that's why we use those products. I wanted to optimize the potential for success, hopefully in that top 5 inches, where we say is probably the most critical in a pavement. So at the end of the 2009 cycle, we went out on a sponsor tour, and this is what it looked like. And that's not too bad. Well, in the Caddo County project, like I told you, was I-40 milepost 102 to 104. It's just, there's Oklahoma City, and there's the project is between Watonga and Hinton exits. And we did a similar thing that we did on the NCAT test track, only we used an OGFC for the wearing course, and they like it out there. It's a good safety layer. Similar 1.5 inches or 9.5 millimeter mixture, but in this case, the Secretary of Transportation, Gary Ridley, said there's so much rutting out in this section. We'd repaired this section because 2 years earlier they did this hot in place recycling, and it was just way too much rutting in this area. So he said, I want to beef up the design and add another layer. So we add another 19 millimeter mixture on top of that. And then that rich intermediate layer, instead of the third lift down, was the fourth lift down on this project. And while we were doing this test, we got those mixtures. We sent them to Nelson Gibson at the Turner Fairbanks Highway Research Center. And I'd presented this data to you before, but this is the one plot that I like showing. There's that rich intermediate layer. In fatigue resistance, that's a lot better than the others, right? And then here is this S5, which is the surface mix. So this is the fourth mix down. This is the top lift, essentially. And then this S3 is that 19 millimeters. This has a recycle in it. We use this on the shoulder, so we're going to go ahead and test it. surprisingly, it did a little bit better than the S3 without any recycle in it. I'm not sure why that was, but that's the way it turned out. Well, as you look at this 5 inches, and this plot is another one from Nelson Gibson that shows kind of the stresses and the damages in the pavement. And up in the top here, we're seeing this compressive stresses and strains, and here we see this even more severe here at the bottom, and this is at 5 centimeters, which would be about 2 inches. So this always happens at the bottom. If you don't get a good tack coat, I don't care what it is, this kind of thing's going to happen right there. So if you got a 3/4 inch Nova chip, or we call it ultra thin bonded wearing course in Oklahoma, and you don't get a good tack coat, which that product generally does a pretty good tack coat, you're going to have some severe failure. And any kind of thin pavement, this kind of thing's going to happen. So that's kind of the thinking of that rich intermediate layer, that if it did bend, it's kind of like a composite on a board, you know. If you've ever looked at a composite board, smooth finish on top, and then this coarser, stiffer material in the middle, and then in the bottom it has a smooth, so that's kind of the concept of that. Well, we went out and did some training for some inspectors at the local level out at Clinton, Oklahoma, which is just west of this project, on January 21st this year. And I said, you know, usually I go out and look at a project, and it's usually, hey, we got a problem, come out and tell us what went wrong. So then I got to go out and do a forensic investigation, and thankfully this one's still doing well. Thank goodness for this meeting. I was afraid it's not. But it did do well. It's still going. I got out in the middle of the traffic and looking here eastbound towards Oklahoma City, and it still looks pretty good. You can see in the plot there, had to get out of traffic pretty quick. There's a lot of truck traffic on this road. Well, we talk about balanced mix design nationally. You go to a lot of conferences, you'll hear this term. And 3 years ago or more, I had some money able to get this 3-year fatigue research project, which is essentially, if you know the NCHRP 957 project, we're looking at mixture fatigue. We were looking at it back 3 years ago. And surprisingly, we have looked at similar things. There's a lot of different fatigue tests, but to balance out your mix design, you need a good rutting performance test and a good fatigue test. And one of the goals there was to select the best fatigue test. Now, the best is relative, right? Is it best in performance prediction? Is it best in time savings? Because as a state lab, we have to do the test, and if a test takes 5 days to do, we can't live with that. That's too long. And if the equipment costs $2 million, we can't afford that. So it's a balancing act, and 947 did a pretty good job looking at those acts, and they selected what they thought was the best. And in this project, we wanted them to set a fatigue test limit, develop a fatigue test method if there wasn't one that existed already, and to purchase and install the fatigue test equipment at the Oklahoma Department of Transportation. See, I'm sneaky. I knew that we wouldn't have money to purchase this equipment, so I made that part of the contract. So I let them, I said, you can use your own equipment, or you can buy new equipment, use it for your research. But at the end of the research, we want you to install the equipment at ODOT. Yeah, I'm sneaky that way. And also I said, you know, not only that, with this mechanistic empirical design guide and everything, we'd like more realistic data and more of it. So I said, we want a machine to test dynamic modulus and flow number. So that's in there as well. I said, on top of that, I want you to train us how to use it, because some of these fatigue test methods and dynamic modulus are pretty complicated. So that's all in the But we chose the semicircular bend test that Louisiana developed, and for various reasons, but that's the one we chose. And we delayed this 3-year project so that we could do more of this SCB test in this long-term pavement performance project, which we constructed this fall. And there's that project. Like I said, it's located, there's Oklahoma City, let's see here, there's Yukon, so it's just right there. Just on US Route 66, if you remember that show, Route 60. Get your kicks on Route 66. Well, that pavement had a lot of fatigue cracking, and that's going to be interesting to see how those various products perform. And I have some tentative results here on it. But if you go to infopave.com, you can look up LTPP projects and put in SPS-10. You'll see data for New Mexico. You don't see Oklahoma's data because that's only updated once a year, so that our data is not in there yet. If you're not familiar with a semicircular bend test, here it is performed in the AMPT, and there's all the way to failure. And they had these different notch lengths that we cut in here. There's 3 different lengths. And of course, the bigger the notch, the faster it cracks, right? Stands to reason. And you plot these on a plot, and then you see how they perform. Well, in that SPS-10 project, we have 6 mix designs that we looked at. There's the layout of it. And our mix design terminology means something. This S4 is our surface mix, half-inch nominal maximum size, 12.5 millimeter, and then design lab number, and then the year it was designed. And then 0 usually indicates the original binder, and then 11 mix designs this lab has performed, and then 0 corrections to the mix design, and 0 job mix formula change. We only allow 3 job mix formula change before they have to remix. But if you want to see if it's a warm mix asphalt design or not, there's a W in it. Right there. So if you see the W, you know it's a warm mix. So we looked at foaming, we looked at chemical-based, evotherm. We looked at some rejuvenating agents there with some evotherm. So a lot of different things we're looking at there in this SPS-10 project. And here's some tentative results. We have 2 mixtures. And that first one, if we set the limit as 0.4 as the criteria that we're plotting on our plot, those 3 data points, and we get a value of, say, 0.488 on this first one. That's on the lab mix. And then on the field mix, it did a little bit worse, and you see the same thing for the warm mix asphalt that's foam, and it's a little bit below this limit. And I believe Louisiana sets 0.5 and 0.6 as their limits. And I've talked to Dr. Louis Muhammad, and he was thinking 0.4, 0.5 might be best. That's yet to be determined. We'll see what we come up with on that spec. Right, here's a plot of the data that they do. It's a typical uniaxial test where you have this loading to failure. You get the maximum there. Well, the Wagner County project is a project that, again, we're going to do some SCB tests on. They're using ground tire rubber. What's the benefit of ground tire rubber? Well, hopefully it'll be more resistant to fatigue cracking, right? Well, this research here is sponsored by the Oklahoma Department of Environmental Quality. They want to use ground tires. So this is the sections layout we're going to do on that demonstration project for the county. We're looking at section 1, which is a PG 70-28, half-inch nominal maximum size. INS is insoluble, means it's a surface mix, so it's 2 inches on the surface. And this is a little bit higher grade than what you'd use on a county road, but we want them all to fairly compare apples to apples. And so the next section is going to have 5% GTR. These are about 3/4 mile sections for a full transport load. And then this one's hopefully a 70-28 with 5% ground tire rubber. They probably start off modifying it with a 64-22, and it is turns out to be what it is. And then our third section here's We've got 10% ground tire rubber by way of the binder, and then 20% on this last one. The rest of the project, they're still using beam mix designs. That's what we used to use in Oklahoma, a modified beam design. And as a type B, which is essentially what we call now an S4, which the 4 is kind of interesting. If you add 10 to that, that's 14. So VMA of 14 for the field and 14.5 for the mix design. So it's kind of interesting. We came up with this naming convention for the mix design. So the higher this second number, the finer the mixture. So an S1 would be the coarsest super paved design out there. So S3 is going to be our base mixture, and S4, S5 is surface mixtures. Okay, so Oklahoma Department of Environmental Quality had some money, and they're sponsoring this research. They've already asked OU to do a literature review. They've completed that. We're going to do some FWT tests out on this project at every layer, including the base, so we'll know what each layer contributes to the pavement. We're also doing the 3 mix designs. We'll just take an existing 70 minus 28 mix design, and then OU is going to do the SCB test since they still have the equipment. So, based on the performance of N8 and the Caddo County experience, and if you consider that NCAT has recommended changing the structural number from the old AASHTO 93 design guide from 0.44 to 0.54, you can reduce your design thickness by 20%. And if you're familiar with Pave Express, you can go through and do an analysis to verify if what I told you was true or not. Looking at this, we have a 6-inch aggregate base, 7 inches on the surface. I said it about 6 million easels, 20-year design life. The default is 30 years. And then I did it, again, assuming the structural number of 0.54, we have 5.5 inches that we can design it at, which is what, a savings of 20%, a little over. Verified that. So if you want to be conservative, and you don't have to be conservative in that program, 20% reduction is doable. If you don't do the reduction, then you've just added an extra safety factor. So ODOT will adopt the fatigue test in 2018. That's what I'm projecting. We'll have the dynamic modulus as part of that. The SPS 10 fatigue test will be completed late 2016, so 2017 we'll be getting the equipment, doing some shadow tests, and then hopefully by 2018 we'll implement the fatigue test. The Wagner County GTR project we're building this spring. So if you look at all this thing, and we talk about balanced mix design, I got to believe that fatigue testing, cracking is the most important. We're also a sponsor at the NCAT Test Track for the cracking group experiment, which is also cooperating with Minroads in some of this cracking experiments in cold weather climate. And they also have some sections in NCAT where they're doing this fatigue. So fatigue is the toughest nut to crack. I don't think you're going to see any specific test adopted nationally. It's hard enough with a rutting test. We have the flow number and Hamburg and APA and various rut tests. You're going to see the same thing with fatigue. Different DOTs, agencies are going to select their own fatigue performance, but anything's better than what we have now. And when we add fatigue, we're going to, I think, exceed what the old Marshall and beam designs gave us. We're going to have a broad spectrum design, and we can actually increase the life of our pavements. Well, I talked about the weather. I hope I didn't strike a wrong note with you. I hope you enjoyed it. If you have any questions, contact me. Thank you.
Ken, thank you very much. Do we have any questions for Ken today? No? Great. Thank you very much, Ken.